Hi, good morning, everyone, and welcome to today's session. So basically, today we will be covering the lecture topic of fish health management, right? But before I begin, anybody has any questions or anything pertaining to the last lecture that we would have covered?
All good here.
Morning. All good? All right, nice. Right. So at the end of the lecture, we will discuss a little bit about outstanding assignments, and I'll answer any questions pertaining to that. Right. Right. So to begin, fish health management. Right now, over the last couple of weeks, we would have covered several different topics in tropical aquaculture, including aquaponics, right? And as you will be well aware, there are many different types of aquaculture systems that are utilized, right? Both locally, regionally, and internationally. Some systems are better suited for us here in the tropics, right? And in small island developing states, simply because of our available land space, etc., which can be a constraining or limiting factor when it comes to large scale production, right? For example, we recirculating aquaculture systems, tank-based systems that we can do intensively are more suitable for us because of the fact that we have limited land space, right? Now, it's all well and good to set up an aquaculture operation, depending, it doesn't matter what type of system that you invest into, it doesn't matter the type of species that you utilize, right? Without proper fish health management, right, no operation will be as profitable or as successful as what we would intend it to be, right? Simply because disease, right, poor fish health causes one, death, or two, distress to your animals to such a point where they will not be performing to the best ability, and they wouldn't put on the desired weight. We wouldn't get the kind of production levels we're looking for, and it will impact negatively on our income earning ability, right? So proper fish health management is key and critical, and it should go alongside other areas of aquaculture production, such as proper system design and management, proper stocking density, proper feeding, nutrition, and different things like that, right? So there are many different areas that must all come together to give us optimum production, right? And again, fish health management is one such thing. So basically, I would first like to define what a disease is, right? So basically, disease is considered to be any condition of an aquatic animal that impairs normal physiological functions, right? So when we think disease, we're probably thinking something like a bacteria, or a fungus, or a virus, all of which are correct. But again, it really refers to any condition. And in many occasions, like we will cover in a couple slides from now, there are other things that affect fishes negatively that may not be things that we typically think of as disease, like parasites and bacteria and things like that. There are other things that will also negatively impact the normal physiological functions of aquatic species and aquatic animals, right? So fish disease outbreaks increase production costs because of, one, the investment loss in dead fish, right? So if you get disease and you suffer losses, right? So your animals die. Remember that would have already been investments made towards purchasing the animal, right? Feeding the animal, housing the animal, operational costs, labor that you pay, personnel, or even yourself to go out and take care of these animals via the husbandry practices and those different things like that. So it is an investment that is lost. And it's not just an investment loss in just the physical animal itself, but also potential income that you also lost as well too. right? Because let me say you invest in a fingerling, a tilapia fingerling, and it costs you $1, right? And you're going out that tilapia to be, let me say, 2 pounds that you would retail for about $20 a pound, $25 a pound. That's potentially $50 you lost. Yeah. So you have to also factor in these things as well, you know, because again, any loss within your system would have a negative impact on your income earning and your profitability of your enterprise. Yeah. Also, right, fish disease outbreaks could cost you a lot in terms of the cost of treatment. In case you need to buy medication, in case you need to isolate these fish and all of these different things like that. And again, all of that is factor into what's your cost of treatment, right? And again, decreased growth during convalescence, right? So basically, once the animals are sick, right, they will not feed as well, they will not do as well, and again, it will show a negative effect on their growth and production, right? So this decreased growth will ultimately reflect as decreased income or profit for you because the animal will not put on weight the way it's supposed to. Right. So just like you are that, you know, you're sick. When you're sick, you don't really eat well, you know, like you might try to eat a little soup, you know, that kind of, but so many people when they get sick, they lose weight because again, they don't function as normal. So just think about it that way for the fish, right? So again, fish health management, right? As I mentioned before, it is very critical to the successful operations of your enterprise. So fish health management describes the management practices that are designed to prevent fish disease. Yes, so you want, again, in fish health management, prevention is always better than cure. It's always better that you put certain things in place to prevent the fish from getting disease in the first instance, as opposed to having to come now to treat that fish. So again, sometimes once fish get sick, salvage is difficult. Now, you have to also bear in mind that we are doing aquaculture, or we basically referring to aquaculture with respect to food production. And there's a difference between treatment protocols for food fish as opposed to ornamental species. Right now, with food fish, we do need to consider the fact that we are consuming this organism or this animal. And because of that, there are very limited antibiotics, there are very limited treatments that we can use for these organisms, because once we treat them with it, some of it is not fit for human consumption. It is fine for ornamentals because the ornamentals, we don't consume ornamentals. We have them there for mostly aesthetic purposes, right? But when it comes to food fish, it's very difficult, right? Especially when it comes to use of antibiotics. Yeah, so we just can't, all right, like we have a bacteria problem, we just hit the best antibiotic. No, it also needs to be approved for consumption. And therein also lies some challenges as well too, yeah? So again, once fish get sick, salvage is difficult. So successful fish health management, again, as I mentioned before, begins with disease prevention rather than treatment. Good water quality management, nutrition, and sanitation prevent fish diseases, right? Because poor water quality will have a negative effect on your growth and your production and survival of your fish. Nutrition, just like with us, right? You know, they tell you like, all right, we'll take plenty of vitamin C and different things like that, build up your immune system so you can help fight disease. Yeah, you can help fight viruses and the cold, right? It's the same thing with all other organisms. Nutrition plays a very important role, right, in disease prevention. Sanitation is also a very important thing as well, right? So when we refer to sanitation, we refer to things as making sure your environment is clean. You don't introduce any foreign objects that may be contaminated and those types of, because that will also pave the way for bringing in disease or allowing disease to have an effect on your organism or your species. Disease results from the interaction of the host fish with the environment and the pathogen. In many instances, your pathogen becoming exposed to a disease or a disease-causing organism, the pathogen that can cause a disease, will not really reflect in the fish showing signs of that disease. So your fish simply interacting with a pathogen don't mean that it will get sick. Doesn't mean that it will show any signs of being ill, etc. There are many different things that need to come full circle for that pathogen to really cause the fish to show signs of disease. And it's really an interaction between the fish, right, the environment, and the pathogen. So again, fish is constantly bathed in potential pathogens, including bacteria, fungi, and parasites. So even though you look at your fish, right, so I know like Siobhan, he has a lot of fish at home, right, because he's a fish breeder and he sells fish, right? So you look at your koi's and you say, well, my koi's are healthy. Nothing is wrong with that because the fish seem to be in good health, they're feeding well, they're doing well, they have no signs of, they have they don't look ill and anything like that. But that does not mean, right, that the fish does not have bacteria in it and on it. It doesn't mean that it doesn't have parasites on it. It's just that the fish has not succumbed to these organisms and it has not reflected signs of disease. But it doesn't mean that parasites are not there. In fact, the majority of fish, especially like in normal natural environments like rivers and they are bathed in parasites, right? If you do a simple skin scrape on a fish and put it under a microscope, you would actually see many different types of parasites there. But the fish seem to be very healthy because the parasite has not affected the fish so that they could show signs of disease. However, if the conditions become stressful for that fish, right, and such as poor water quality, reduced oxygen, high ammonia, things that negatively affect the fish and really take that fish out of that, neutral state that it's in, the parasites proliferate now because the immune system of the fish would have decreased, etc. And when that happens, disease takes hold. And you start to see the fish looking sick. You start to see different parasites. You see the fish, the fins become clamped. And depending on what parasite or what organism is there, you really see the effects of that organism now. So it's really just an interaction between the pathogen, the environment, and the organism. And the environmental conditions are, in many cases, the responsible factor for that parasite or for that disease pathogen causing an effect on the fish. So again, poor water quality, poor nutrition, immune system suppression, that is generally associated with stressful conditions, allow these potential pathogens to cause disease. So again, just like with plants, when you have it out in a garden or you have it in your farm and your plants and stuff, daily observation is critical and is key. So daily observation of fish behavior and feeding activities allows early detection of problems when they do occur, right? So it's always good to pay particular attention of your organisms, of your animals, right? Now, one key thing is that one of the first immediate signs that something is wrong with your fish is a decrease in the feeding of your fish, right? Or a change in the feeding behavior, right? That's one of the most early warning signs that there's something wrong, right? It can either mean that something is wrong with respect to disease of your fish or poor water quality, but you know that once feeding is negatively affected, or once the fish does not feed as prolific as how they would typically feed, you know something is wrong. And at that point is the point in which you would try to troubleshoot now, whether it's poor water quality, whether it's some sort of pathogen affecting your fish, etc. So you could start to take preventative, or not even preventative, proactive measures to prevent this either pathogen or poor water quality taking a strong hold on the fish. Yeah, so you want to kind of start to deal with it one time. Like I said before, disease results from the interaction of the host fish with the environment and the pathogen. Yeah, so you can see where the circles, like in Maths 6, in Maths we learn, the intersection and all these different sorts of things, right? So as disease really takes place when the conditions are right for the pathogen, and it takes effect And there's an interaction again between the host, the pathogen, and the environment. So it's this little section here when all come together. So stress and disease. Like I said before, disease will take hold on the aquatic organism in most instances when the animal is stressed, right? So basically stress is a condition in which an animal is unable to maintain a normal physiologic state because of various factors adversely affecting its well-being. Yeah. So again, water quality is key. Once water quality goes bad, those are key stressors, right? The different parameters on fish. Yeah. So if you look here, you can see an example. Low pH, low dissolved oxygen. These are poor water quality parameters, right? And those are environmental. And they put stress on the fish. Low dissolved oxygen, the fish can hardly breathe, so they kind of suffering for oxygen. Low pH, right? Which is called acidosis. We will cover that just now. Those things stress the organism. It causes stress on the fish. When fishes are stressed, they typically produce hormones and different things like that to deal with it. Stressor hormones, right? It causes things like exhaustion and different things, and then disease could take hold on the organism. Right. So again, stress is caused by placing a fish in a situation that is beyond its normal level of tolerance. Right. So remember when we did water quality and different things like that, I mentioned that every different type of organism has particular water quality conditions that are best suited for that particular organism. Right. So like temperature, for instance, we covered cool water species, warm water species, cold water species. If you take a fish that is adapted to a cool water environment and you put it in warm water, of course, that water temperature is not suited for the fish. So it will cause stress on the organism. And when that stress occurs, the fish body or the fish normal reaction would be to basically produce different types of hormones and stuff like that to deal with it, right? And it will cause things like exhaustion. It will start to take a negative effect on the fish. Yeah. So again, stress is really putting that fish beyond its normal level of tolerance, taking it out of its optimum. Different stressors exist, and there are different stressors in fish, right? So basically, here are some examples of typical stressors. What causes it, etc. So 4 major categories of stressors are chemical stressors, such as poor water quality, pollution, diet composition, metabolic waste, etc. Causes could be things like low dissolved oxygen, improper pH, intentional or accidental, like chemical treatments and insecticides. So once these get, like, let me say insecticides, for instance. That's why when you see Ministry of Health and things passes around a lot, there's always asked if you have fish and stuff around your property. Because the sprays and stuff that they use are chemicals, and if it gets into the water, it could cause stressors to your fish, or it could become, depending on the quantity, it could become toxic and it could kill your fish. Yeah. So those are some examples and causes of chemical stressors. Then we have biological stressors, right? So things like population density, other species of fish, right? That may cause, like, let me say, we have fish that are normal omnivorous or herbivorous, feeding inside it. They have them in the tanks, and then you introduce a carnivorous fish, right? So definitely we have a predator-prey relationship existing there. So it could cause a stress on the fish, right? The herbivorous fish that just they're minding your own business because he's not potential food. And this could be and the predatory fish could be now a biological stressor, right? So that's other species of fish. So you have aggression, territoriality, all of these things will affect that fish. You have microorganisms, macroorganisms. So all of these are biological stressors on your fish. You have physical stressors, things like temperature, light, sound, dissolved gases, right? So these play important role on the immune system of the fish. And then we have procedural stressors like handling, disease treatments. So handling is one of the most common forms of procedural stressors. So let me say moving a fish from a smaller tank to a bigger tank, that causes stress on your fish, right? Any form of handling should try to be avoided as best as possible because it can cause stress on your fish. Yeah. So we have any questions thus far? Okay, good.
So
All right, question.
I have a question, but I'll ask the question after you do the disease resistance because it's
All right, sure,
related.
sure. No problem. So disease resistance. So again, just like regular people, right? Just like ourselves, all fish do not get sick. Not saying that we are fish, but all fish do not get sick and die each time a disease outbreaks occur, right? So we could see that with COVID-19, right? A lot of people getting COVID-19 and they have different levels of susceptibility. And that is normal. That is expected because we are all humans, but we have different immune systems. We have different ways our body will react with it, even though we are the same species. It's the same thing with the aquatic species. Not all get sick and die each time a disease outbreaks occur, right? Normally, the most vulnerable, the most susceptible are the ones that show that effect. Yeah. So many factors affect how an individual responds to a potential pathogen, right? So the potential pathogen is one example, right? So the pathogen itself, it could be bacteria, parasite, virus. It must first of all be capable of causing disease, right? Two, the host fish must be in a susceptible state. So remember that little diagram I showed you just now. I think they call it a Venn diagram. Yeah, I think so. Okay, the whole matter. Right. So you had the pathogen, bacteria, parasite, virus, and either it must first be capable of causing disease. Then the fish must be in a susceptible state. So even though the fish not in a susceptible state, those pathogens may not take hold on the fish, right? So again, poor water quality could put that fish in a more susceptible state. Certain environmental conditions must be present for a disease outbreak to occur, such as one or more of the stressors previously listed in the table. Yeah. Right. Question.
Yes, sir. In Trinidad and Tobago, we tend to be very corrective instead of preventative. So let's say we have a system where pathogens were introduced into the system. How do we get rid of the fish pathogens in the tank?
Right. That's a real good question. So the question is, well, you all would have heard them, right? If we do get pathogens entering into our system, how do we get rid of it or how do we deal with it? It will first of all depend on what type of pathogen it is. Depending on the pathogen, then we will have to prescribe a particular treatment for that pathogen because there's no one-off treatment or one-all fix it for all the different types of pathogens. It's specific to the disease-causing organism, whether it's viral, parasitic, fungal, etc. Right? And even, let me say, we look at the pathogen being parasitic. Even depending, you need to even go further now to determine what type of parasite it is, and then do a treatment to get rid of that from the system specific for that parasite. So it all depends on what the disease-causing organism is. In most instances, right, we treat the fish. Yes, that's one, right? So the first thing we do when we observe the signs of disease in our system, we take the affected fish out. That's the first line of that's the first step in treating with this issue. right? You take all the supposedly diseased fishes, you remove them from the system and you place them into a separate system for treatment, right? So you treat with those, you determine, and then you determine, what is the cause, whether it's a specific parasite. So let's use a parasite as an example, right? And we know that, let me say, is parasite X. Right, so we know we would identify what the parasite is or who the parasite is, and then we would prescribe a treatment for the fish specific to that particular parasite, because other parasites may require something different to deal with it. Right, so you treat the fish. With respect to the system, in many instances, it may be difficult to deal with the entire system at that point in time. Right? So we just treat with the sick fish. We could probably perform like a partial water change, etc., to reduce the parasite load if it's present in the water, right? So that our other fishes may not become affected. And we would want to keep the conditions inside of that system as best as possible and as optimum as possible, because remember I told you, even though the parasite is there or the disease or the pathogen is there, right, it will not show effect on the fish unless you have like the stressors and all of those things. So we want to remove all those stressors as best as possible. So in most instances, we don't necessarily have to treat with the system right away, depending. If it becomes so problematic that we need to treat with the entire system, right? So let me say we got bacterial problem in the system. Now, bacteria is very difficult to deal with. So in some instances, depending on what the bacteria is, so I'll give you an example. There's this bacteria called Mycobacterium marinum. It is the quote-unquote fish form of tuberculosis. It's something that is ubiquitous in the environment. It is present throughout Trinidad. A study was done by some research students in the School of Vet Med in the recent past, and they assessed myco in populations throughout the country. Right now, if aquatic species that you're culturing for food is affected with Mycobacterium, the recommended treatment is cull your entire population, strip your entire system, drain out all the water, and treat it to remove that bacteria. So you could treat it with dilute bleach, you could treat it with 70% alcohol, or any other recommended treatment for that particular bacteria. Yeah, but those are some of the most effective treatments: bleach or alcohol, right? And you strip your entire system out and you flush the whole thing to sterilize it. Of course, you will have to start back over your entire production cycle. That is an extreme example, but it is sometimes one of the means by which we could sterilize the system, because to really sterilize, you have to get rid of all our water, flush it out, and then sterilize all the components that may have been in contact with that disease-causing organism. So again, depending on what causes the disease what causes the disease, we could simply just take the affected fish out, treat those, make sure the water quality and everything is on par, so there are no stressors present to cause the other fish from showing signs of disease. Yeah, and again, depending on what the disease is, we may need to strip the entire system to the extreme and deal with it like that. So it's all about sterilization, and you have to sterilize all components. So you see how extreme that could be, right? So this is why it's so important that you prevent the disease from getting into your system, or the pathogen, in the first place. Sometimes it's unavoidable, but you have to try your best as possible. How we do this? How do we really go about preventing this pathogen from entering the system? Right? So the first thing is we set up a system. We have no fish in it. So let me say that is step one. We set up a perfectly functioning aquaculture system, water quality, everything is on par. Time to introduce fish. Now, the first step that you do when you're introducing fish into your system, these recommended protocols here, right, is to do a screen on your fish. So it's called screening. So you take a few fish from the intended population that you're going to stock, and you do some sampling on them. You test them for external parasites, you test them for certain bacteria, certain viruses, dependent. In most instances, we will screen for parasites by taking little skin scrapes, fin clips, and stuff like that, putting it under microscopes and looking to see what is present there. If we determine there are certain parasites there, we could do a treatment, a prophylactic treatment, to get rid of that parasite before we put it in the system. So even though stressors occur in our system later down, it doesn't cause a negative effect on the fish because we ultimately would have removed that parasite in advance. So that's one of the first steps we take. The second step, and what is also recommended, is that in an aquaculture facility, we have what is called a quarantine area. And we keep our fish under quarantine sometimes between 14 to 21 days, on average 3 weeks. So let me say we set up our aquaculture facility and we get a batch of fingerlings to stock in that facility. So let me say we have on average 500 fish. We don't just take them fingerlings and put it into the system one time. We take it, we put it into a quarantine system, which is a separate system that is not as elaborate as our growth facility, and we observe them for a period of 14 to 21 days. So let me say we observe them for 21 days, and over that time, we want to just keep an eye on them to make sure that they don't show any signs of disease. Usually, if a fish is infected, it's like COVID-19, right? Let me say you come in contact with somebody with COVID-19. And you go on, the same thing, you go on quarantine. It's the same term. So basically, one of the primary reasons for quarantine is really to see if you're infected and to see if you will show any signs of infection over that specific time, because that time is usually enough time for the virus to show its effect. So when we get a fish, or a batch of fish, we don't know when or where or how or what they was exposed to in advance. So we will treat it as day one. We would assume there was exposed to something today, and then we'll put it into quarantine. And over that period, at 14 to 21 days, is sufficient time for most any disease to show its effect if the fish was infected. So after that time, if everything is fine, we do our checks and balances, and we skin scrapes and and everything. We will take the fish and put it into the system. What is even more important is if we already stock with system, we have healthy populations of fish, and we bring in a new batch of fish. This is where the problem will occur now, because we don't know what this new batch of fish coming in with. So let me say we have a system stocked with 5,000 fish on it, and we bring in 50 fish. It's very important that we put those 50 fish on quarantine, and we make sure that they have no signs of disease. Because imagine if you bring in 50 juvenile fish and you introduce it into a system with 5,000 fish, adult fish that is almost ready for harvest, and then 50 fish cause disease to spread to them 5,000 fish. That's like literally shooting yourself in the leg, because if you just introduce 50 juvenile fish and it almost costs the entire investment. So quarantining is very important, right? So those are some of the things that we could basically do to really prevent disease from getting into the system in the first place. And then after that now, well, not even after, but during that whole process, we practice proper biosecurity. Meaning, all right, yeah, we have a fish, but anything that we put in contact with the water or the fish, we want to make sure that it's sterilized. So our fish nets, we don't randomly dip our hand in the water to handle any pieces of equipment or anything, because we don't know what our hands have on it, right? We don't know what the fish net have on it. So what we do, we sterilize all equipment, including if we have to put our hands in contact with water, we sterilize our hands too. Just like COVID-19, they tell us use hand sanitizer, wash our hands, because we could transfer the virus to ourselves from environmental surfaces. Same thing. We don't know where in the environment, so you don't want to take what's in the environment and put it into your system. Yes, so again, these are some of the preventative measures we could take to avoid pathogens from getting into our system. Anderson, dilute and do a water change. Yes, correct. So it is advisable, even if you determine that there's disease and stuff, or things negatively affecting the fish, you take the disease fish out and you do like a water change, because it will reduce or get rid of whatever is in the water. Sterilizing the surfaces of your tanks and thing will only be done in like the extreme, because you will have to remove everything from your system to do that. Yeah, by Jabez. So you can be real pressure. So again, preventing disease. Now, I will give you a real-time example of a situation where all of what I just told you did not happen. All right. And it happened to me, but not just me. So in UWE, right, we had a display coming up, right, at the vet school. It was something called open house, right, where we, for I think 2 days, we invite all schools, the public, to come and look at all the and view all the different departments and stuff like that in the vet school. And so, well, I was basically involved with the aquatics unit, so I did their systems and stuff for them there. But I mean, it wasn't as bad as us taking random fish and putting it into existing system. We had individual aquariums, individual tanks, right, that we was using for display. But because the event was like the next day, we went and we now got the fish, right, that we was putting out for display. But thankfully, each batch of fish was going in a separate tank, right? So they was isolated from each other. So it's not that all the fish mixed together, that if one batch was affected, all would have been affected. It wasn't that case. The problem happened when we set up these tanks very elaborate with substrate. So we had like driftwood, we had gravel to the bottom, we had all these different things inside of the system. And then we introduced the fishes inside of there. I mean, it was like an emergency, because we need to kind of put the fish in for the next day, right? So we placed in those fishes, and guess what happened? After the expo that ran for about 2 days, that open house, in the week after, a couple of those aquariums, a couple of those batches of fish came down with serious parasite problems. The whole skin, everything, the scales, everything got white. It was something called ick, right? Which is something that is very common. It's a very common parasite, and it could cause mortalities, because it will multiply in such high numbers. It can kill your fish. And these fish came down with ick. But the problem with ick, remember I told you, depending on the type of parasite or the type of pathogen, the treatment will be different or specific for each one. So even amongst parasites, so there are many different types of parasites, Chilinodella, ick, dinoflagellates, all these things, right? There's some examples of parasites, fish parasites, external parasites. Ick is a very problematic parasite because it has something called an intermediate life cycle. So for part of the life cycle of ick is this impermeable little capsulated stage that lasts a couple of days. So like a normal parasite will lay eggs, like a fly. It will lay eggs, the eggs will remain, it will hatch, it will turn into larvae, turn back into a fly. So that's intermediate life stages, right? So egg to larvae to fly, that kind of thing. So that ick has a life cycle like that. But you see that egg stage, it is impermeable to treatments. So even though you take all the fish out and you do a treatment inside of the tank, if the eggs still remain, it is encapsulated and the treatment will not affect it. And then after a couple of days, even after you do treatment, it's going to hatch and it's going. Yes, hello? I think I got cut off for a minute with the internet. You all able to hear?
Yeah, so we are now.
Okay, great. Thanks. Yeah, I don't know until what is internet. Let me see where I reach.
Yes, so you was explaining to us how to treat it.
Right. All right, nice. Well, so I didn't also left far. I'm just trying to find back my slide here. Just 1 second. I think I read somewhere here. Right. Yeah. So yeah. So treating that ick could become very problematic because let me say, all right. So salt dip or salt like regular salt, right? If you make up salt to the strength of seawater, right, it can kill, right, most external parasites, right, or not even most, all external parasites of freshwater species, right? So it's a very simple treatment that you could use, right, especially when you have, especially on the fish itself, right? And we're going to talk about this a little later on. But in any case, right, treat an egg. So let me say you have a treatment for egg, right? You have a chemical that you're using to treat egg. And you take that and you sterilize the system with it. The thing about it is, it will kill all the adult egg, right? It will kill all. It will get rid of it. But you see that egg, that live stage of that egg that is unaffected or impermeable to any sort of chemical or anything like that will remain. And in about a day, 2 days, 3 days, it will hatch and it will form back more egg. So basically, it evaded the treatment. So when you treat an egg, you have to treat consecutive for about 2 to 3. I think it recommends about 3 days, every couple of days apart. So that way, if there was eggs at some point when the eggs hatch, it would have come in contact with that treatment. So that way you could fully get rid of all the egg from your system. So anyways, so back to the story. So the fish came out with egg. And because egg has an intermediate life stage, you can imagine the kind of headache now. We had to go now, take out these fish, treat the fish in a separate tank. Take all the equipment that's inside of there now, because now we don't know where the eggs are, right? Or the intermediate stages of that egg. And have to perform multiple treatments on the tank, multiple treatments on the driftwood, multiple treatments on the stone, everything that was inside of the aquarium. Right, there's a lot of work to go back and empty. Some of the tanks had sand and all to aquarium sand, so it was a long time. Don't clear back all and then go back and set back up the entire system. Now, ideally, what we would have done is place those fishes in a clean tank without any substrate, right, and just observe them. So in case we even detected a problem with the fish, we could have just applied the treatment in that tank one time. So those quarantine tanks, you could do treatment, and those they designed for that. It's much smaller units that just designed so that to allow for easy treatment in cases needed, right? Sometimes aquatic facilities even have a separate section for treatment. So there is a display and a production section. There is a quarantine section, and then there's a treatment section. At the School of Veterinary Medicine, we have a facility there where we have those 3 sections, right? We have a display and a production section where only clean, healthy fish are kept for breeding and for production. We have a quarantine section. Any new fish goes to the quarantine section, and they are observed for any signs of disease. And then there is the treatment section where anything that we pick up in the quarantine section that is abnormal, we put it into the treatment section and we treat it. Right, and once the treatment is completed, we put it back into the quarantine area, make sure everything is okay, and then put it back into the production facility. So these are how more the advanced, facilities are. For you as an average farmer or average aquaculturist, right, these things could just exist within your facility, But you want to make sure that there's no mixing of equipment in these different areas. It's very critical that in your quarantine area, the nets you're using does not come into your production area. The hoses you're using does not come into your production area. Even when you yourself are dealing with these different systems, always treat your production area before you go and deal with your treatment or your quarantine area. So that way, let me say you're going to your quarantine area and you do a water change or you handle up your fish there. All right, you have different nets and all these things across in your production area, but you yourself is the same person and it didn't sanitize itself properly. And let me say you dip your hand in by mistake or you got a splash, and whatever pathogen that your fish had that you didn't even know about as yet in the quarantine area was on you, it now could transfer from you into your production area. So you always deal with your healthy fish first and then you move along that order. Yeah. Right. So protective barriers against infection. So just like us, we have skin, right? Our skin is a protective barrier. That's why when they get cuts and bruises, we could get infected, right? And it could cause us to pick up and get infected with pathogens from the environment. Same thing with fish. They also have skin and scales, and that is a protective barrier. So when you're handling fish, that's why fish nets are made with the material it is made of, so that it doesn't cause abrasions on your fish. Because if it becomes abrased, it could lead to potential pathogens in the environment affecting and infecting your fish. So yes, methylene blue and acrylflavin safe for aquaculture treatments, potassium permanganate as well. Siobhan, you see methylene blue, right? That will work a little good for, like, I know a lot of persons like to use methylene blue. It's really good for like some fungal problems and things. For most things, it's not really that recommended, but I don't think it has any negative effects, especially for aquaculture production. What you really want to not use for, and you have to be mindful of, is the treatments for bacterial infections, right? Is really those antibiotics. That's one of the most critical. Everything else I'll just have to double check. I don't think even potassium permanganate as well, I don't think that has any long-term effects, negative effects for your fish. Yeah.
Yes, I think when I was doing the checkup on them, I think the acraflavin is
Right.
in the UK. I think it banned over there. But the methylene blue is tend to work for ick.
Yeah. But it's not the best for ick. Honestly, the best for ick is a very simple treatment for ick that anybody could access is that salt treatment.
Yeah.
That's salt bath.
What PPT that is?
Right.
Bracket.
So a prolonged bath is 30 to 33%, 33 to 33 PPT if you're doing that dip. Right, and if you're doing a prolonged treatment, around 3 PPT, because it could keep your water slightly saline, at 3 PPT indefinitely, because the internal environment. Sorry, class, it's just going a little off point, right? But don't be any mind if you're confused, right?
But
so the internal concentration of aquatic species fish is around 6 to 7 parts per thousand. So the internal environment of a fish is not fresh. It is slightly saline. So keeping the external environment slightly saline, like around 3 PPT, could actually even further reduce stress on your fish. And this is what most people don't understand. So if your fish is stressed, you could actually reduce stress of your fish by adding some salt to the water. You will see it on many hobbyists side, but most hobbyists don't understand why they add salt to the water. Right? Salt also has good properties to prevent infections and stuff like that. But another effect of salt is that it reduces stress on the fish because it starts to keep the internal and external environment close to what the internal environment is, and the fish needs to expend less energy in maintaining that balance. And that's the science behind it. Yeah, Anderson.
So this is salt for even freshwater fish you're talking about as well,
This
right?
is for freshwater fish, correct?
Okay.
This is for freshwater fish.
That's
Saltwater
something I
fish.
would have think totally different. Hey, you can't add salt to any freshwater fish. But I understand
No.
what you're getting at.
Yeah. So the recommended salt is rock salt, right? Now you could use, people do use table salt, but the problem with normal table salt that we use for cooking is that it's very high in iodine, right? And you don't want to expose the fish to, while iodine is needed by all organisms, you want to avoid a situation where you're exposing them to more than what they need. Yeah, so that's why we avoid salt, table salt, and we use what we call rock salt. Yeah, that is free of iodine. But salt treatments they work really well for external parasites. Now the reason that works that way, right? Because freshwater parasites are microscopic; they're very small. So when you expose them to a high concentration of salt, right, it causes, you all recall this thing called osmosis and these kind of things that happen when you put like something moves from a more concentrated to a more diluted type environment, a natural process. So what happens when you expose parasites to a very high salt concentration? It basically causes the water within the parasites, because they're fresh water, to pull out, and it desiccates out that parasite, and it immediately kills them, sometimes within seconds. They can't withstand that high salt concentration. The fish, however, are much larger. So if you dip them in a high salt concentration, around 30 parts per thousand, the parasites will immediately be knocked off, because it's so microscopic that 30 ppt is a real big thing for them. It's not so much of a big thing for the fish. So over a couple minutes, the fish will do fine. Once you keep the fish in that condition for a couple minutes, now the recommended treatment for a salt dip is that you make up your bucket or your container with a concentration of around, I saw the hands raised just now. You make up that bucket, that concentration of around 30 parts per thousand. You take your fish, your freshwater fish, you put it in a net, and then you just basically rest that net in that salt, right? You usually keep them there no more than 10 minutes. But you keep them as long as you would, when you place the fish in there, you would see them keeping upright and they will be moving fine. But after a while, they will start to turn to the side. That is called the roll, right? ROLL. It's called the fish rolling, right? When that happens, you immediately take the fish and you put them in fresh water, right? So the fish will recover themselves, but all the parasites would have dropped off the fish that time, because the salt concentration was too strong for the parasites, and it would have killed them, but just mildly affected the fish. If you have saltwater fish, you do the reverse. You take pure fresh water and you dip them in that. And the reverse will happen. The saltwater parasites, the same kind of effect will take place, and the parasites will drop off and die, and the fish will more or less remain fine. Right? So again, it is very important that you know whether you're dealing with freshwater fish or saltwater fish, and how you go about treating with them. So freshwater, you put them, you expose them to salt water, and saltwater fish, you expose them to freshwater, just the reverse. And it can help remove the vast majority, if not all, the external parasites. Right. So we had a hand was raised.
Yes, sir. For the prophylactic treatments, which is essentially antibiotic treatment, etc., you said that
Right.
antibiotics might impact the system. When you was talking with the other guy, it said that antibiotics might impact the system. I'm assuming that it might impact the growth of the plant, maybe water quality, the nitrification, biofilm, and whatever nutrients
Correct.
microorganism we might have in the system. But before you cut off, you said that we should take the fish out of the system and then give them the prophylactic treatment. My question is, how do we know when to reintroduce the fishes into the system, maybe to prevent the excretion of the antibiotics in the system?
All right. So let me just make one thing clear. A prophylactic treatment is really a treatment to give fish in advance of any sort of disease or anything like that. So like you see that salt dip that I talk about, that's a prophylactic treatment. The regular treatments you will give a fish like antibiotics, you will only give fish really antibiotics if they show signs and you determine they have bacterial infections. Right now, when fish show signs of disease, you take them out and you treat them for whatever is causing that disease, whether it's parasites, virus, bacteria. Right. So you try to avoid putting antibiotics into your system itself, because again, antibiotics, it will have a negative effect on your biofilter. Right, it will have a negative effect on your biofilter, and it will also more or less kind of persist a bit in your system. So you really want to take the infected fish out of the system and treat them. How do you know when to put them back in the system? So let me say the pathogen was a parasite, and you take the fish out, they were showing signs of disease. You test the fish. Of course, there are certain protocols for testing. You test for parasites and all those things, depending on what. It's like you go by the doctor, and the doctor asks you a series of questions, and then he determines you have a cold. It's the same thing with the fish. You look at all the signs and symptoms of the fish and determine whether it's bacterial, parasitic, and those things. So if the fins reddening, if you're seeing lesions and those kind of things, right? So once you determine what it is, you treat appropriately. So let me say your fish had a parasitic problem. You take the fish out, you determine what parasite it was, you treat the fish for the parasite. So you basically do like a skin scrape on the fish, which is basically taking some mucus and scales of, sometimes there's some mucus and stuff of the fish, putting it under the microscope, you determine what the parasite was, etc. You treat the fish. So you give it the recommended treatment. Before you can put the fish back in the system, you do a next test again on the fish. So you do a next mucus evaluation, etc. under the microscope to make sure that the parasite is gone. Once the parasite is gone, you put it back into the system. If the parasite is still there, you go back and you reapply a treatment again. So before you put back a fish into the system, you want to make sure that that fish is generally back in good health, right? And then you place it back in the system. In some instances, after you do the treatment, you keep the fish in quarantine now for the quarantine period to make sure that there's no outbreak, that the fish doesn't show signs within that time, and then you put it back. Again, just like COVID-19, if you're suspected of being infected, or you come in contact with somebody who was infected, you go on quarantine, you keep yourself there for whatever, around that 3-week period. If no signs within that time, you report back out to work. If you get infected with COVID, you wait out the time that that virus will usually remain within your system, and then you remain home for a further period of time to make sure that you have no further symptoms, and then you report back to work. The same thing with fish in a quarantine system. If your fish is sick, you take them out. So that's like they had the COVID. You put them out into the system, you treat them, everything like that, to make sure that they show no signs of the disease anymore. And then you wait a little period again to make sure that it's fully gone. And when you determine it's fully gone, then you send it back into the system. That's clear enough?
Yes, so just the last part, in terms of how long the antibiotics would last in the system.
Oh, that will be specific, sorry. That will be specific to the antibiotics that you're using.
Okay, cool.
Yeah, that will be specific.
Yeah, you ever had any problems with Aeromonas hydrophila?
Yeah, we treat Aeromonas really caused by poor water quality, yeah?
Yeah.
It's caused by poor water quality. So the key thing with Aeromonas is see all them detritus and all them, like especially in ponds and thing, you want to clean out that water as clean as possible, because Aeromonas really take hold when you have like real contaminants and thing in your pond, decaying organic matter, poor water quality generally. So good water quality management is key for Aeromonas.
So what was some like real high nitrates, like over 180 ppm?
Nitrates?
Yeah.
Yeah, well, nitrates could have some effect on fish as well too. You know, you want to, when nitrates go really high, see the reason why I don't get, in most instances, we don't really talk much about high nitrates is because it is the end of the ammonia conversion process, right? So the ammonia toxic, the nitrite's toxic. The ammonia not so toxic unless it builds up in high quantities. But it is anticipated that when you do clean your filters, you drain out your filters and you add back some fresh water. So water is always causing a dilution effect in your system, right? But sometimes nitrates does build up to a high quantity and you really do need to do a partial water change just to get rid of that concentration, unless you do aquaponics. And that's why plenty of people opt in for aquaponics. So that way, your biofilter will take care of the ammonia and the nitrites, but your biofilter produces nitrates, but your plant removes nitrates. And that is all you really need to do to kind of keep that aspect of water quality in check.
Mhm. Yeah, well, I do some of that craziness you was talking about. I get some fish from somebody. And I say, yeah, man, you gotta worry about them. Throw them in the tank. Yeah, everybody's sick.
Yeah, boy. Nah, that's be real rough. That's be real rough. So I real particular about when because I get shot from there already many times now. So
Yeah.
I mean I learned the hard way because I mean before I became quote unquote professional in aquaculture, I was a hobbyist too. Right? The majority of my life I was a hobbyist. I didn't know all the science. You
But the
understand?
The thing is, we know better. I know better. I'm not supposed to do that.
But that is the thing. You don't have any excuse. Back then I didn't know nothing. Right? I didn't know anything. I suggest, oh, look, more fish. And I just, every day, like if I get one fish, I train that. I said, go in the river. The worst thing you can do, especially when you get fish from like rivers and thing and you bring it in. That's when people tell them they were theta and they were, this thing, sushi, and they want cascadoo to put as feeders to remove any uneaten feed in the koi ponds and the fish tanks. I just look at them and be like, you're sure about that? Right? Because those fish you're bringing in has a very high probability of having plenty parasites because natural systems has a lot. And the fish just seem, guys, let me tell you, I wish we could have do this experiment and look at that see for yourself. We could have got a couple of rivers. You would see fish looking perfectly healthy in there. As soon as these fish come out in a matter of days and you put them in a tank, you will see a canting developing one time. That happened to you, Shivam?
Yeah, I get some sardines recently.
Right.
And some river guppies because I have a little mud pond with such a mosquito larvae.
Right.
And yeah, they had it. I had to put them in some methylene blue.
Exactly. And they don't seem that way when you catch them in a matter of days.
Perfectly healthy.
Yeah. And you see, again, it comes back to a shift in what? External and conditions. And you see, this proves what it is I'm talking about. Yeah, and external environmental conditions, once it changes from what the fish is accustomed to and is best for them, it causes that stress. It may not seem apparent to you because to you may take a fish out of a river and put it in an aquarium, clean water, nice air pump and nice filter and everything. But that water condition, it just creates even though the water quality is good, it's still not what the fish was accustomed to. The fish adapted to that water in the river over its entire life. So that shift will cause a stress on the fish, and then the parasite will take hold.
And then remember, you handle the fish. That will add additional stress to them, and then you put them in the little collection vessel before you get them to where they're going to go. That's additional stress.
That is more stress again. Just a movement alone is stress.
Yeah.
So you know that even when you're transporting fish, some of the things that it is do, right? One of the things is to do it as I told you to do. Increase the salinity of the water.
Yeah.
So you can actually put some salt in the water to keep the fish calm and reduce stress. And another thing is to reduce stress, especially for shipment. They sometimes put a mild anesthetic in the water as well too.
Yeah, to knock them out. Yeah.
They do that, yeah, they do that, right? They put a mild anesthetic, and the reason for that is because this fish now is inside of a bag. Yes, it have oxygen and everything. Transport is overnight, but the fish will beat up in a bag because it's trapped in a bag in a dark box, and they're just moving from one continent to the next. They're going and beat up and stress themselves, and that stressful environment could lead way for the fish to start to show signs of disease. So again, reducing stress on the fish is very important to preventing disease.
Yep.
Right, let me see. Joselle have some event here. Let me see. I took a river fish, a small one, I put it in my fish tank with my 3-inch fish, and it's still living now. I surprised nothing up. Yeah, Giselle, you dodge a bullet, right? So that's good. I mean, it's not all times they're going to spell disaster, but there was a very high chance that river fish could have had parasites because it's happened all. I mean, I was be dealing with fish up to last night. I was in Caroni River sampling fish, right, and getting different fish for some displays and things. So I mean, I could tell you a lot of times, a very high probability, 80% of the times when you take fish out of that environment and you keep them in a tank, they will start to show signs, especially this thing called ick. That's very common. Yes, so you're lucky, and try to avoid doing something like that next time. And if you catch your river fish, keep it in a separate tank, keep it for a couple of days, and make sure that it's not really showing any signs of disease, and then you can put it in.
Yeah, them fish that I brought from the guy who gave me the cascado.
Right.
Because some cascado he gave me to put in 3 flathead and a couple of the round heads, the usual ones that I keep.
Oh, good.
They come with ick, and they come with the aromonas. So what happened is some of the other fish, because remember my fish not really exposed to parasites. Their barbels started to rot, and then they started to get spots on these, like you know how the bacterial wounds look on the side?
Yeah. The skin and thing was started to come off. You will start to see parts of it being eaten away.
Yeah, and that really licked them up. That aromonas.
Mm-hmm.
That's why they ended up losing the entire batch of babies I tell you I had the first time.
Right.
But what I do is I use this antibiotic, what's the name of it? You know, it is cephaloxin.
Right.
That one, I use that one, and I cannot get rid of it.
Okay.
That's a lesson. Yeah, that's a lesson.
No, yeah, that's definitely a lesson. That's learning the hard way, but at least now it didn't affect your breeder, so thankfully for that.
It was actually breeders. It was the breeders.
That was a breed. What?
Yeah, I lost about 6 of them. Or 8.
Okay.
Very good.
Yeah, you want to keep that. And this is our next good point for you, Shivan. See now how you're breeding. You see them breeders you have?
Yeah.
Boy, let me tell you see the net you're using for that. Make sure keep them breeders isolated from every single thing you're doing.
Yeah,
that's the rule I just follow home. Even while using a bucket, I don't even move a bucket between my breeders and my production tanks. I keep separate. Like I want to keep my breeders because I could afford to lose some stuff from a production because I could get back that and poiking, but breeders is harder to get. Breeders are selected quality breeders. You want to make sure your brood stock is. That's like the goose that lays the golden eggs. I mean I could lose all the golden egg or two, but my goose can lay again. But so you want to make sure your brood stock is kept completely isolated.
One of the males that died, that was a fish that was nearly like 250, 300 grams. It was a big fish.
Yeah, boy.
Yeah, but why if I have to sterilize the nets, I would dip the net in potassium permanganate.
Right.
Like mix up a strong concentration and dip
Yeah.
And I keep them separate.
Right. And always work good to iodine. They sell iodine. You could do an iodine dip. I think it's like 5% or something you have to do. I could always give you what we used to use. Bleach and all too, you could do a dip. And most times you just let it sit for a couple of minutes, take it out, let air. It's the important thing when you're sterilizing is to let everything air dry after. Yeah. So it could take its effect and then you could rinse it out.
Yeah, let air dry and put it out in the sun.
Right, nice. Sun is also good. Mr. Anderson say he had and the son mentioned about some fish that he got that didn't survive. And again, it's true because fish are adapted. Remember, it don't matter you have clean, pristine conditions. If a fish acclimatized and they're adapted to a certain type of water quality conditions, and then you put them into somewhere contrastingly different, the fish would have already adapted its physiological function into that environment. And that change in environment, that sudden change, the fish could go into a form of shock, and they could die as well too. Yeah, so you're right. Not really, Siobhan. You don't really have to test the water the fish came from. What you want to do is make sure that your water quality is good with respect to your ammonia, your nitrites, your nitrates, your oxygen, and different things like that. Yeah. So
Yeah, well, we will try to match the water parameters as much as possible.
as much, yeah. Yeah, and this is one of the reasons why when you purchase fish from a pet shop, they tell you to float the bag in the water for a little while. That way you can keep the water temperature. You can try to keep the boat match the boat temperatures to one, so the fish can take its time and acclimatize to the new temperature. And two, sometimes they tell you take a little bit of the water from the system and kind of put it in the bag as well. So that way the fish can start to, even though the physiological parameters are different, they can start to kind of acclimatize a bit to that as well. So it doesn't become a sudden shock to them when they go into the new environment.
I had one more question, right? With regard to the aquaponics systems, right? If you have a mass disease outbreak in terms of parasites, right? You wouldn't necessarily be able to solve that tank to clean it out because remember
plants here do like sodium. So that becomes a little bit of a problem. So you try to best to sterilize as much and as best as you could.
Right.
Yeah. All right. Nice.
So, just a quick question before you continue. You ever had any experience with UV treatment?
With what?
UV treatment.
UV treatment. UV treatment, yes, they do work. So UV treatment is also a type of filtration. It actually classed as a type of filtration, right? UV filtration. One, it will help with like algae and those things, but it will also help to a certain extent with bacteria in the system as well. Because if bacteria is present in the water and it passes through UV sterilization, it can actually reduce the density of the bacterial load in the water as well. So it helps us to an extent also, as well as with some other microorganisms.
Yeah, so with regard to the UV treatment, right? One of the filters that I have, they have a UV light built into it. So what I did was once I noticed the fish was getting sick, I saw the water and I plug in the UV light. So any floating bacteria in the water, the UV light would help with that. And then the salt would help with that. But then when I added in the antibiotics to treat the fish, I unplugged the UV light because the UV light might degrade the antibiotics.
It might degrade the integrity of the antibiotics, correct. That's some good stuff there, Shivan. And that's some good reactive measures to take there with getting things, and proactive measures with actually having the UV and thing in place to begin with.
Well, I wasn't proactive in ensuring the crazy fish inside the tank.
Nah. It happens. Yeah, Jabez. Any more questions?
All good.
All right, nice. Right, so again, back to protective barriers against infection. Fish possess 4 protective barriers to protect against infection: mucus, scales and skin, inflammation, and antibodies. And this is almost something that is common with almost all organisms, except for maybe the mucus part, right? We do produce some mucus as well too, in our nasal passages. That's why when we get sick, you notice we get runny nose and all them thing, and we get smacked, right? So again, mucus build up. We don't have scales, but we do have skin. We get inflammation if we got a cut, right? Because that's our bodies naturally fighting things off. And we know we're going over COVID right now with the vaccines. We're trying to build up antibodies. So when a fish gets infected, it goes through almost the same thing that we will go through, right? It will get infected. The body will produce antibodies. It will start to recognize, them kind of thing. So we could look at this as almost the standard with most organisms, right? So The first, mucus. Right, so the first protective barrier is mucus to a slime coat. So mucus is a physical barrier that inhibits entry of disease organisms from the environment to the fish. It is a chemical barrier that contains enzymes and antibodies which kill invading organisms. It lubricates the fish with aids in movement throughout the water. Right, so basically mucus is a little slime coat. If you ever held a fish, there is a measure of sliminess to the fish. If a fish becomes infected with parasites, the mucus layer gets very thick and it affects the fish a lot. Yeah, it infects the fish a lot, right? So you actually get a much thicker mucus layer developing on the fish, right? So scales and skins. Yeah, so we have a question. You hear me now, Anderson? You're able to hear, right?
Yes, sir, we hearing good.
Okay, I think Anderson he wasn't hearing for a little bit. Anderson, you able to hear now? Yes, everybody is sharing good. So I think Anderson, you could probably check your mic or on your speakers on your computer. Right. So mucus, again, it performs several functions. Scales and skins function as a physical barrier protecting the fish against injury. Well, that's more or less obvious. Straightforward. Inflammation. So inflammation again is a cellular non-specific response to an invading protein, and that protein could be a bacteria, virus, a fungus, a parasite, a toxin. It's characterized by pain, swelling, redness, heat, loss of function. Just like with us, if we got a little cut or a little chip or something, you know, it's feel burning, a little pain, redness, that kind of thing. It is a protective response and an attempt by the body to wall off and destroy the invader. Yeah. Antibodies is a specific cellular response. So in antibodies, you have molecules formed to fight against the invading protein or organisms. Antibodies formed at the first exposure. So this is why we take vaccines. So the body, in advance of getting infected from the real pathogen, we could produce some antibodies in advance of that. So the body will have memory cells. So when we do get infected, it quickly produces antibodies and deals with the foreign organism before it could cause any form of serious disease and illness. Right, so prevention of stress and disease, good management prevents stress. This means maintaining good water quality, good nutrition, good sanitation, right? So good water quality involves preventing accumulation of organic debris and nitrogenous waste, maintaining appropriate pH and all the water quality conditions. So again, I mentioned poor water quality is an important stressor of fish. Good nutrition, proper sanitation, well, I touched on those before. So disease types, right? So basically diseases could be classified into two broad categories, infectious and non-infectious. So infectious diseases are caused by pathogenic organisms present in the environment and could be carried by other fish. They are contagious and some type of treatment may be necessary. Non-infectious diseases is caused mostly by environmental problems, nutritional deficiencies, or genetic defects, right? So those don't really transfer from one fish to the next, yeah? So they're non-contagious. Infectious diseases could be broadly categorized into bacterial, parasitic, viral, or fungal, right? And parasitic diseases most frequently caused by microscopic organisms called protozoa. Bacterial diseases, again, caused by bacteria. Viral diseases, viruses. Fungal diseases, fungal spores, etc., funguses, all right? Non-infectious diseases. So again, they're broadly categorized as environmental, nutritional, or genetic. Environmental diseases are the most important in commercial aquaculture. These diseases include low dissolved oxygen, high ammonia, high nitrite. It could be natural or man-made toxins in the aquatic environment, right? So proper techniques for managing water quality enable producers to prevent most environmental diseases. So again, you see how everything interrelated. So your so your system design, setting up your proper mechanical filter, your proper biofilter will help maintain your water quality. Your water quality, well, the integrity of your water quality will be maintained by having a proper design for all your filters and different things. And by having good water quality, it will prevent non-infectious diseases from affecting your fish, right? So you see how starting with a proper system design helps maintain good water quality. Maintaining good water quality helps prevent non-infectious diseases affecting your fish. And once your fish is not affected, they remain in good health and a good physiological state. So they grow to the optimum. And in so doing, basically, you achieve your best production. Yeah. Right? So these are some examples of non-infectious diseases: oxygen starvation, alkalosis, acidosis, nutritional deficiency, poisoning, brown blood disease, anemia, gas bubble disease, and genetic. And I will now just give you just a brief example or a brief explanation of what each one is. Right, so just give me 2 minutes. All right, nice. So again, non-infectious diseases. So these result from an animal's reaction to environmental changes, and these are some examples. Oxygen starvation. So reduced dissolved oxygen levels causes oxygen starvation. And again, all organisms need oxygen for, aquatic organisms need oxygen for basically survival. So if that oxygen level becomes low or below the acceptable level for that organism, they will become extremely stressed. Disease can take hold, or the fish can just die just from a lack of dissolved oxygen as well if it goes too low. Alkalosis occurs when the water becomes too basic for the species. Remember when we did pH, right, for water quality, I told you that fishes require slightly alkaline, maybe around 8 to 9, a pH of around 8 something, right? Between 8 to 9. The thing about it is, every aquatic species has the most optimum pH, but if the pH goes too high or too low, it could cause either alkalosis or acidosis. And it's basically the names given to when the water goes, the water quality goes too basic or too alkaline for the species on the extreme end, or it goes too acidic or too low for the species on the lower end, right? So too rapid of a pH increase or a pH decrease could either cause alkalosis or acidosis. And again, this is one of the other reasons why it's very important that we match these water quality conditions. Yeah, so if you're wondering how fish from the river mightn't do well, and because again, the different conditions sometimes could cause a sudden stressor on the fish. Nutritional deficiency is a deficiency. A nutritional deficiency can be caused by unsuitable food, too much food, too little food, a vitamin deficiency, etc. So it's just about proper diets and everything like that. So again, knowing what type of fish you're cultivating, you can target a specific food for that fish. So carnivorous fish versus herbivorous fish, the requirements will be completely different. Carnivorous fish will need a lot more protein in the diet because that is what they adapted and they evolved to consume. So a diet that has too low protein may cause a protein deficiency in carnivorous fish, and then they will get nutritional deficiency, etc., and then show signs of that non-infectious disease. Poisoning. Any toxic substance or toxic levels of a substance in water could poison fish. Wrong blood disease. When nitrites accumulates within the system, I would have mentioned this when we spoke about when we did water quality. That nitrite, so remember you have ammonia converted to nitrites and then to nitrates. That nitrites just bind to the blood, the hemoglobin in fish's blood, and cause something called methemoglobin. Basically, it's referred to as brown blood disease, and it is a disease where the blood could no longer effectively transport oxygen, right? And that in itself is problems, right? Anemia. So again, poor nutrition or chronic disease can cause anemia in fish. Anemia is the inability of blood to carry the oxygen. Gas bubble disease. Basically, affected fish shows bubbles under the skin, under the gill tissues, etc. This occurs when the water is saturated or super saturated with oxygen. The oxygen can actually, or it can actually go under the skin, under the scales of the fish, etc., and cause these bubbles there, right? And that is called gas bubble disease. It could also have genetic diseases, and this caused by genetic abnormalities, right? So you get conformational oddities such as a lack of tail, a deformed looking tail, the fish might be a little twist up. You see it all the time, and if you're a fish breeder, not all the fish will come out uniform. Shivan, you ever saw this before when you're breeding fish? Any fish come out looking deformed?
Yeah, I have about 3 of them in an aquarium here.
Yeah.
I have some real unique ones too. I have some cascade with like black streaks in the top fin.
Right. Yeah.
Yeah, kind of cool.
Yeah. So again, you do get genetic abnormalities and things, but this can spread to other fish, unless you use them as breeders and they can spread the genes. But other than that, to say that it will be contagious, no. So determining the presence of disease. How do we determine the presence of disease? The most obvious sign of a sick fish is the presence of dead or dying animals. Right? The fish can have that. Of course, they have disease. Something is wrong. The careful observer could usually tell the fish are sick before they start dying, because sick fish often stop feeding and may appear lethargic. They will stop moving around as vibrant as how they was moving before. And when you feed them, they wouldn't be feeding aggressively. When I was running the facility at MedSci and vet school, right? So we had various aquatic systems there. One of the things that we always took note of was the feeding behavior of the fishes. So we actually had a record book that had each tank. Of course, it labeled with each species, because every species has a certain feeding behavior. So you first need to know what is the feeding behavior of the species you're dealing with. Some are aggressive feeders. They will just swim to the surface and look like they're fighting with each other and just gulping down the food. Some will take the time and they will come and take a little bit of food at a time. It doesn't mean one is feeding better than the other, right? Because you first need to know what is typical of the species. Once you know what is typical of the species, you grade them on about 1 to 5. So if the fish is feeding at level 1, right, it means it's feeding normal for that species. So like take tilapia, for instance. They want to throw food, they get plop, 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 you get wet and thing. They start to splash up and they come to the surface, aggressive feeders. So feeding like that is good feeding. So I will class that as 1. If they're coming up and they're feeding aggressive, but they're not really swimming and hitting up each other like they're feeding, and all right, that's about 2. And then while they go down in that aggressiveness, it will be 3, 4, which is hardly feeding at all. And then 5 is completely not feeding. So we basically have to go by each tank, know what the behavior, the feeding behavior of each fish is, and grade them every single day. When we notice now, so sometimes they go between 1 and 2, because not every day they will feed as aggressive. But once you realize it starts to drop and the feeding behavior changes to such a point where they hardly even feeding, you know something is wrong, right? Because they can refer back to your log now and say, hey, like this fish was feeding at 1 every day for the last 5 days. Why they going to 3 or why they going to 4? Why such a sudden change? So that feeding behavior is an indicator, like one of the first indicators that something is wrong, water quality, disease, something they are affecting them fish. Because if everything is fine, they will be feeding as usual. Yeah, so everybody follow me with that? Nice. So again, feeding behavior is very important. Healthy fish should feed aggressively if fed at regular scheduled times. Fish that are observed hanging around, not moving much in water, gasping at the surface, rubbing against objects indicate something may be wrong. In addition to behavioral changes, some physical signs should alert producers to potential disease problems in fish. These include presence of sores such as ulcers, hemorrhages, rag fins, abnormal body conformation like distended abdomen or dropsy, exthalmia or Popeye, basically the eyes getting big and distended from the sockets. So all of these are good signs that physical signs that something is wrong with the fish. Methods of treatment, various methods of treatment, and it depends on what is causing the fish to be sick. There's also room for drug application to control certain types of diseases in fish. So the dip is what I told you about with the salt, right? So basically a dip is basically a treatment where you have some sort of chemical in a body of water. You take your fish, you expose them to it for a very prolonged, for a very short period of time. So hence the name dip. It's really expected that the fish go in there for a very brief time and then back out. The best way to perform a dip is to keep your fish within a net and take that net with the fish and put it in the system. Your dip, because a dip has to be for a short period of time. Sometimes 14 to 45 seconds is enough time, it's a matter of seconds. Do you ever take a fish and let them inside of a dip and then try to catch them back here? Because if your window extends for too long, it could cause problems, right? It could cause negative effects on your fish. So always keep your fish in a net, put them in a dip, take them out. Depending on the dip, it will have its recommended period or time to leave them in there. A bath is something where you keep your fish in there for much longer. So dip is short, couple seconds. Bath is for like an hour dependent, right? So they're for a little bit of a longer period of time. Feeding, you could apply medication or treatments via feed. So if your fish have internal parasites, you could load that fish food with the recommended treatment and feed your fish it, and they will eat it and consume it and get the anti-parasitic drug going into the intestine, etc., via feed. And then you could use injections for large and valuable fishes. Of course, your if you have a big aquaculture facility and you have 5,000 fish or 10,000 fish, injecting it might not be feasible. But if you have high valued koi's and one or two fish become infected or become diseased, of course you want to take all precautions. It makes sense to use injections to come and try to get it the best treatment to your fish. Yeah, so that's basically it there for fish health management. That will more or less cover some of the more core areas of fish health and some things you need to consider in keeping fish healthy for your production. And again, well, we see why fish health is so important. And again, for us, prevention is always better than cure. I will always recommend doing this thing called having proper biosecurity, which is basically all the steps you will take to prevent disease from getting into your system, out of your system, or transferred between one system to another system. Do we have any additional questions?
I think I asked enough questions for the day, but I am good. The information that was shared today is really good information.
No problem. No problem. Right. So I'm glad that you appreciate it. So I actually, well, in terms of fish health, right? So apart from me being an aquaculturist, I had maybe around 20, about over 8 years experience working in aquatic health medicine, right, at the School of Vet Med. So I have like around 8 to 10 years experience there. In addition to that, I would have also done fish health from the University of Florida. So it's like vet med for fish. So I would have also worked with a fish health specialist, right, which is a vet specifically trained for fish, right? And while working at vet school, we actually did fish surgeries there. I will look for those photos and I will show you. Believe it or not, you can't take a fish and put it under anesthetic and perform a surgery. Go and check, just like how you will do on a normal animal. But of course, there are certain criteria that you will need to put in place to keep the fish alive out of water, right? So I actually built so I modeled this design I saw online where you had a stream of water flowing over the gills of the fish and the body of the fish while the fish is under surgery. And this stream of water has has the drugs in it to keep the fish sedated, right? So the sedatives are in the water and it keeps the fish knocked out while they perform the surgery. And we actually went into a fish, open up the fish, do surgery, stitch up the fish, and then put it back in water. And then the fish recovered and thing as usual. I think they did an entire video for it, but I don't have a copy of it, but I do have photos of that. We even did we even did this thing, what do you call it? Where you take ultrasound on fish. We did x-rays on fish and look at the skeletal system, like bones, just like normal organisms. So there's an entire area of medicine devoted to fish as well, too, just like you would have for normal terrestrial organisms. What courses? Yeah.
With regard to the prawns, right? What kind of diseases they're prone to? In terms of parasites and bacterial, I know they get some bacterial infection, but in terms of parasites.
Just now, hold 1 second. Okay, about 2 minutes there, Siobhan. Yeah. Yeah, Shivan, sorry about that. What was the question?
So I was asking about the prawns, right? What kind of diseases they could get? Also I was asking, well, I was typing it out. What type of do you know where we will be able to get injectable medications for like certain types of fish, like for kois? Like I had a koi one time. He had a bacterial infection with Aeromonas.
Right.
The client who was dealing with it, he actually took the sample and took it to get it tested, and it came back with Aeromonas hydrophila and something else. I can't remember what it was. But that's how I ended up finding out about the cephaloxin. And well, the other thing I was asking you about was for the feed for the prawns, right? You use the sinking type feed, the Ziegler Silver.
You could use any sinking feed. I use normal here as crack regular NFM feed and it sink to the bottom.
And is it that?
The prawns, yeah.
All right. Anything else you use to supplement?
You could put like if you have any like fish or anything like that, that of course is healthy, you know, you don't want to put any diseased fish. The omnivorous as well, that's like for the crayfish. But for the prawns, I try to give them a bit of protein as well as that. And there is some recipes you could find on YouTube that will show you how to make diet, something that you're blending up like fish and all them thing in it together.
So you cubing it up and basically.
Yeah, like a kind of little egg custard kind of thing, something along them lines.
Yeah. I think I did see the egg custard one time.
Yeah. So with respect to diseases, it will be specific to the species. Some are more susceptible. Also, the geographic location. So in certain parts of the world, you will get certain diseases that will not be found in other parts. That's why there's be very particular when you're bringing in animals in the country, both fish as well as other livestock, because you don't want to bring in something that the country don't have in it.
Yeah, that's why you had to get a vet certificate.
Yeah, correct. So there's correct, right? So again, that is a little more specific to the organism and when you will it is. Josel asks, so what courses you need to do to get into that job? Josel, that is more of a veterinary medicine type thing, right? So you would have to do some sort of veterinary medicine program. If you want to get more into like fish health and treating aquatic animals and those things, because once you're doing treatments, you have to be doing treatments. It had to be along the kind of more doctor veterinarian side of things, because you have to get licensed and things to be able to practice medicine itself. So whatever program you're doing, you have to be able to get a license to do that. Like me, I could tell you everything wrong with the fish or whatever the case is. I could probably treat it and all them things, but I would not be recognized as somebody certified as a vet. Like that's especially even to practice veterinary medicine, you have to have a vet license to do that, to purchase drugs and those things. Shivan, no problem. Any vet could prescribe medication to you for fish, right? Any vet, right? So they could write a prescription for the antibiotics for you once they know what it is and the treatments and stuff like that.
Right. But for the injectables, they would have to do that themselves.
Yeah, because again, medicine is not, that is part of their ethics. That is part of what they're trained to do. It's not, we wouldn't recommend that just regular persons do it. Although on farms and stuff, a lot of people do it depending on how simple the procedure is. They could go ahead and do it, but it is recommended any sort of real treatment is done, because there's certain means, like just given an injection, there's a whole set of training you have to go through, proper way to advance the needle, to keep it sterile, those things. So we don't expect like the average person to have go, because that's part of medicinal training. Right, so it's many different techniques you will have to go through to understand how to use a needle, what type of needle, what size of needle, how much to put in, how to advance it, where to inject it. Because if you inject it in the wrong place, it could be problems. Right. Them type of things. So
part of your part of the biosecurity that I saw when we came up to UFS, right? You will have a kind of water.
Bath, correct. A wheel bath.
Yeah.
Yeah.
Right, so that's after you all buy a security for that for the farm.
Yes. And then to go into each unit,
Yeah.
there should be a footbath as well. Right?
Oh,
So like
yeah.
when my area is completely enclosed, because we're not building it up there, you will be required to at least step into a footbath because we don't know what the bottom of your shoes have in it. But if you go like in the rabbitry and in those other areas we have around the farm, there's a footbath to go in there before. And in that, there's a sterilizing agent to just kill viruses, bacteria, fungi, and those things that may be on your shoes.
All right, so good information. Thank you.
No problem.
Oh, yes, sir. With regard to the, you say was when I mentioned the group project, right?
Yeah. I'll comment to that now. Any other questions?
No, sir, but I just wanted to say that I wanted to do oysters for my individual assignment. I don't know if you want me to communicate to you officially through the WhatsApp group.
Yeah, send it to the group now. So I will just put everybody in a table and I will start to get some information and thing and send it your way as well.
Okay. Say doing oysters.
Oysters are good enough because the higher potential. We do have any oyster farms in Trinidad and people consume oysters all the time. We're dependent on catching oysters and harvesting from the swamps and thing, and most of those areas polluted. So even if it's set up a oyster farm in a more or less pristine area, that could even be a good, like, it's good business, it's good aquaculture. I was actually in some discussions with some people who came to actually set up some projects in Trinidad. I was just about a couple months ago, ending up last year. And one of the things they was looking at is setting up an oyster farm. Yeah, in some places in South. So again, that's something that's needed and it's a real good species.
Yeah, I saw this. It's plenty new information about it online too. So should be good research.
Yeah, for sure. Yeah, Anderson.